Hi guys, Nevada Virtual Academy Algebra, Mr. N here. Let's talk about absolute value functions, today's lesson, right? We had a discussion in class about what an absolute value function is. If you guys remember, if you have an absolute value expression in it, that will definitely make an absolute value function. And we use example 1 from your manual. Here you have example 2, the g of x, right, equals negative absolute value of x plus 1/2. And to find its value for the specified x, in this case negative 3/2, all you need to do will be to plug that into your function's expression wherever you have x. And as you can see in the example here, right, g of negative 3/2 will equal negative absolute value of x, which in this case is absolute value of negative 3/2, plus 1/2. Now absolute value of that negative 3/2 is going to be positive 3/2, right? But make sure you're not forgetting the sign that's already outside, which is a negative sign. Next step, because you have negative 3 over 2 plus 1 over 2, this is the same as negative 3 plus 1, everything over 2, and this is how you get negative 3 plus 1, which is negative 2 over 2, and that's how your answer here will be negative 1, right? Same story with g of 1/2. Good. Let's see some other problems. We talked in class about graphs of absolute value functions. Remember, you need a t-table or a table of values, right, where you will use your x inputs to find what the value of function is for each one of them. As you can see, the most basic, how is it called in your manual here, absolute value function will be f of x equals absolute value of x, right? And obviously, the value of this function will always be positive. No wonder, right? Because if you plug in all the real numbers and you're trying to find their absolute value, and remember from class, if this is my 0, and supposing I have a number a here, right, the distance of my number to 0 will be what it represents, the absolute value of that number a, right? Same story if I have a number here, let's say b, the distance of my b to 0 will represent the value of my absolute value of b. Okay, so f of x in this case, for whatever x you're using, positive or negative, will always be a positive value, right? And this is basically taking you back to the definition of absolute value, right? If you have an absolute value of a number x, this will be equal to negative x, right, if your x is less than 0, and equal to x if your x is greater than or equal to 0. Obviously, if x is 0, absolute value of 0 is 0, because 0 is 0 units away from itself, right, from 0. Okay, as you can see the graph here, for x equals negative 3, you have a 3, negative 2, you have f of x equals 2, or f of negative 2 equals 2, and so on. Okay, we talked about this in class. For some reason, the recording is missing for the lesson, so please go over this for the next problems. Okay, you see examples there you can find them in your manual at page 305. All right, more examples, more solutions to the given examples, right? You have a word problem here, they're showing you how to solve that. Let's see problem number, how about 1, right? Let's start with number 1. f of x equals x plus 1. You need to find the value of f of negative 4. What do we have to do in here? Well, substitution, right? F of negative 4, and we can go right away in here, and wherever you have x, right, you will substitute negative 4. So it will be absolute value of negative 4 plus 1. Okay? Now, you will work following order of operations, and you should consider your brackets like parentheses, right? You will do them first. Inside the parentheses, inside the brackets here, you have negative 4 plus 1, which is negative 3. And now we know that the absolute value of negative 3 will be 3, because that number, negative 3, is 3 units away from 0. And this way we solve part A of the first problem. Part B, f of negative 1 equals, same story, instead of x, right, in your function, you will plug in the value negative 1 plus 1 equals, right? Inside the brackets, negative 1 plus 1 will cancel out. You will have absolute value of 0, right, which is 0. Okay? Let's try another one. How about, we did 11 in class, but like I said, the recording is not there, so I can, try again for the ones who were absent. And let me try to, okay, much better now. Q of negative 6 will be absolute value of negative 6 minus 1 times 1 minus negative 6. Now this is the trick here, right? Be careful, man. When you plug in instead of s negative 6, make sure not losing any one of the negative signs. And this equals what? Well, negative 6 minus 1 will be negative 7, right? Because you're adding the opposite. Negative 6 minus 1 becomes negative 6 plus negative 1, right? Which equals negative 6 plus negative 1, negative 7. In the other one, because I'm subtracting, I'm adding the opposite. I'm changing both signs, and that will become absolute value of 7. And obviously, everything here will be positive, right? So it will be 7 times 7, and this gives you 49. Same approach with part B. Alright, moving on. Okay, for the next problems, you are asked to complete the table and then graph your function, right? Let's do any one of them. How about number 14? And allow me to zoom in here. Okay, so first of all, you need to complete that table for your function, right? And in class we talked about creating a double T table. And this, when I'm saying that, I mean, something that looks like this, right? Where you have your input, n in this case, your output, C of n, right? Or just C, or just Y if you want, if you talk about X and Y. So basically your input is going to be X and your output is going to be Y, right? So for this case, I know that C of n, and I can create that here, and I can put C of n equals absolute value of 0.5 n, right, minus 1.5, everything in absolute value. So in this third column that I just created here, we will find, step by step, what is the value of C of 0, C of 1, C of 2. Okay, C of 0 first, right? C of 0, wherever you have 1, you're going to plug in 0. This will be 0.5 times 0 minus 1.5. Well, 0.5 times 0 is 0. You're left with the absolute value of negative 1.5, which is 1.5. And that will be your first one, 1.5. Okay? Next one, C of 1. And hold on a second. Okay, we're already using the thinner line here. Okay, okay, will be absolute value of 0.5 times 1 minus 1.5. Absolute value equals 1. Well, 0.5 times 1 would be 0.5. So I have 0.5 minus 1.5 in absolute value. Well, here, if I'm performing that, 0.5 minus 1.5 equals 1. When you subtract 1.5, you add the opposite of 1.5, which is negative 1.5. The rule says subtract the smallest absolute value. So 0.5 from 1.5. That gives you 1.0, right? And keep the sign of the largest one, which is negative. This will be negative 1. But because it's absolute value, you will get 1. And this is what C of 1 equals, right? C of 2. Absolute value of 0.5 times 2 minus 1.5. Everything in absolute value. What equals? Well, 0.5 times 2 will be 2. Will be 1, I'm sorry. Minus 1.5 will be negative 0.5 in absolute value will be 0.5. Right? So you get 0.5. C of 3. And many of you are already, I hope, and I know in class you guys did it, you were able to find what would be the next number. You may see a pattern here, right? It goes down by 0.5, right? So it goes 1.5 to 1. I'm taking 1.5 away, taking 0.5 away, 0.5 away from here. This should be 0. Well, let's check it out. I have 0.5 times 3, right? Because n is 3, minus 1.5 in absolute value. Well, 0.5 times 3 is 1.5, minus 1.5, that will definitely be 0. So we're good. Alright? Now what happens with CO4? CO4 equals C4, very powerful explosive, right? 0.5 times 4 minus 1.5 equals 1. 0.5 times 4, that gives you 2, right? Minus 1.5, everything in absolute value, will give us 0.5. And if you follow every one of the steps, you will realize your function becomes symmetrical about, x equals 3. You'll have 0.5, you'll have 1, and for the next one, C of 6 will be also equal to 1.5, same as in C of 0, right? Okay, now with all these points, you need to construct your graph, right? And let's see if I have enough room on this page to show you that. Yeah, I have it right here on the right. We can do it. Okay. Now I'm checking my n, and for n I will use x. Okay. So I will name the first column. Okay, hold on a second. This will be the x column, and that will be the y column, right? So x goes from 0 to 6, y goes from 1.5 to 1.5. I only need the positive part, the positive y-axis, right? So while my and the positive part for my x2, because all those values are positive. So that's your horizontal axis, and this is your vertical axis, right? Now we have, y, which is your C of n, and this is x-axis, which in this case will represent the value of n. N goes from what? N goes, as you can see in this column here, from 0 to 6. So the highest value I will need here will be 6, halfway 3, and you should break each one of the other parts. And you have 1, 2, 3, 4, 5, and 6, right? Your y goes from 0 to 1.5, so if you want you can make 1.5 here. Let me say this is 1.5. As you can see, I'm using a different scale. It really doesn't matter, as long as you're consistent on the y-axis, you will be fine. And we're moving on. First point. Okay. All right. First point is 0 and 1.5. right? Which is basically your y-intercept right there on the y-axis. Next point. Next point. X is 1, right? We're here. Y is 1. So 1 and 1. Now I forgot to label, right? That's 1.5. This is 1.0. This is 0.5, right? And obviously the origin will be right there. So going back to the second point, to the next point. The next point is 1 and 1, right? So I'm going with a vertical line from 1. Make sure you pass the 0. And then with an horizontal line from 1, from y equals 1. Right, line parallel to your x-axis, whatever the two lines intersect, that would be your second point. And I should use handwriting, right? There you go. Alright, next point. For the next point, again, you have 2 and 0.5. So from 2, you're going up with the vertical line until you meet 0.5, right? So make sure you pass that 0.5. And then from 0.5, with the parallel to x-axis line, you will intersect the first one, and that gives you your third point. There you go. For the next one, 3 and 0, well, that's our x-intercept. The point is going to be on the x-axis, right? Moving on. For 4, I have 0.5. 4, you go up with the vertical line, you pass the point 0, right, 0.5, and then from 0.5, which is already there, you're going to go ahead and extend that and intersect your perpendicular from 4, and this gives you your fifth point, right? Next one, 5 and 1, right? 5 and 1. From 5, vertical line, 1 right there. From 1, you need to intersect this line, right? And obviously, we don't have, 100% accuracy in this graph, but I expect that, will be pretty much fine, right, doing this graph, and you will be fine on your paper. Remember, these are the steps you have to follow. If this is part 2 of your test, you have to show me how you make the table, how you get the values, how you plot the points, and the points should be there, and then you will have your graph. For the last one, we have 6 and 1.5, right? So from 6, we're going up with the vertical line. Make sure you pass, the 1.5 altitude if you want, right? And then from 1.5, you'll go with the line, with an horizontal line. Whatever the line crosses your other one will be your last point to be plotted here. Final step, connect your points, right? Because you need to graph the function. Let's use, I don't know, how about purple? You have, this branch of your function, and then you have the other one. Now, as you can see, we are a little bit off. I mean, talking about accuracy. Your points here should be, on the line. We are not, 100% accurate, like I said, because of various reasons. You may see that probably one thing that messed up my graph was that this one unit here is smaller than the next one. Anyway, but these are the steps you have to follow. Okay, you show this on the paper, and you will be fine. And eventually, you may say, I'm plotting first pair 0 and 1.5, and you can put it here 0, 1.5. Right? The next one 1 and 1. The next one 2 and 0.5. Right? The next one here, that's 3 and 0. The next one 4 and 0.5. Okay, and the next one 5 and 1, and the last one here 6 and 1.5. This is one way. Another way is to just call, okay, this is point A, B, C, D, E, F, G, and eventually on the graph you're gonna label them A, B, C, D, E, F, G. This way, no matter who's correcting your paper, will have no doubt that you understand how to graph this function. Okay? Alright. Now we solved in problems a few, a few of these examples, if not at least 2 of them, right? Here you're required to write a table of values for this graph, okay? And this is probably the easiest part. What are they asking you to do is to, do a reverse engineering kind of thing. You basically go back to where you started from the final product, right? And I read in the news that they're figured out how to unboil an egg. Kind of crazy, right? I mean, you may say, well, that's impossible. Well, looks like the science people think different. They were able to take it back to the gooey liquid kind of form. Okay, x and y. Well, I should have said, well, b, right? Let's do it that way. B, right? First of all, B is your input on the x-axis, right? And z of b, zb, b and zb. All right. How should you solve this problem? Well, first point, right? This one here. What is its x? -3. What is its y? -7. And you got your first pair. Next point, what is its x, right? -2. What is the y? -5. And you got it, right? Next one, -1 and 3. Okay, next one, -1 and -1 and 3, right? You see that? Right there. -1, -3. Then you have x0 and y -1. And you move on, all the way to the right by determining what the coordinates of these points are. And you have 1 and -3. You have 2 and -5, right? As you can see, your graph becomes, and it is symmetrical about the z axis or y axis as usual. All right. Well, okay, this is it for today. Please go over the lesson in your manual. Please go over the study and the lesson on your online course, right? Unit 1, subunit 1.07, absolute value functions. Let me know if you want to work extra, if you need extra help. Usually I am available in the afternoon, but make sure you don't have any other class connect. And if you want to work with me, we can schedule that, okay? Otherwise, 8 to 9 o'clock in the morning, that's always a good time. But we can talk, and I will talk to each one of you individually, and we'll take care of that. All right, thanks again. Let's go for it.